Okay, and we'll get started. Is this the right button? Yeah. Okay, so right, yesterday we were dealing with refraction, right? And you can see a lens is just a device that causes refraction, right? So there are two types of lenses: converging lenses, which are convex lenses. You can see the shape of it, and they converge because the light, you can see in our ray diagram, the light when it passes, it then passes and ends up converging and causing an image, right? Whoops. So ray diagrams, the difference with a converging lens and a diverging lens, which will be convex or concave lenses. With lenses, you can see there are two focal points. There's a focal point on the object side, and there's a focal point on the far side of the object. Okay, because there are two curves in the lens. Okay. So our rules are for lenses when we're drawing our ray diagrams are right parallel to the principal axis and then bend to the focal point is ray 1. Ray 2 goes through the near focal point down here, ray near focal point, and then parallel to the principal axis. And again, where the refraction rays intersect is where our image appears. If you want to put a third ray in, we draw it straight through the center of the lens. And the concept here is that it's going in perpendicular to the lens, right? In terms of refraction, in terms of Snell's law. So it just passes straight through in terms of our drawing. And you can see it meets here and converges at where the image is. Converging lens. Okay? Converging lens. This is the one that makes a real image. You can imagine, right? What makes it a real image is the light is actually here. All right. So if I put a screen, I should be able to project the objects here as an image. So that's the demonstration I'm going to do. So I'm going to stop sharing and try to do the demonstration here and see if we can get it to work here. You can, whoops. All right, so there's my lens. Here's my object's going to be my flame. And I have my paper here somewhere. What I have? Oh, there it is. Right, that's my screen, and we're going to try and project the real image onto the screen. I'm going to turn the lights off, dim the lights a little bit. All right, dim the lights a little bit so hopefully we can see it a little bit better. Okay, hopefully we can see this. I can get this going here. All right, stay. Okay, so here's our converging lens. And nope, that's not it. Nope, there it is. Okay. Right. I don't know if you can see, I'm sure you can't see it very well. Maybe if I turn it this way. Right, so you can't really see the, there it is. All right. I know you're having a hard, you can't really see the image. Here you can see the light, but it's circular and it's not focused. But you can see the light's actually passing through. When I get it in the right position, you can't tell, but you can actually see the flame from the um, from the candle. You can see the whole shape of the flame. And if you remember from the slide, and I didn't emphasize this, so you might not have noticed, the image is inverted, it's upside down, right? It's an upside down image on the screen. This is how the lenses in your eyes work, right? By the way, right? The object, the light from the object comes through, passes through the lens at the front of your eye, and it focuses that image on the nerves at the back of your eye. That's called the retina, I think. I think it's called the retina. And then your nerve endings, then it's upside down at the back of your eye on the retina. And then your nerve in your brain switch it back to right side up in your as you're able to see things. Okay. Your eyes have converging lenses. Now, obviously, the focal point has to change depending on how far away the object is, right? If I put on a different lens, I'm gonna have to move the camera back. With a different focal point, I did this morning, so it should work. Oops, crash. Different length focal point. See if I can get this one to, where's the right combination here of object distance to image distance. Struggling with getting it to find my image. Come on. Nope, still not right. You can't tell. There it is. It's so big that I can't even get it to focus on the screen in camera range. Maybe if I move it, nope. Come on. There it is. Okay. And I put it in a position that you can't really see it very well. You can kind of see the image there on the screen, but different focal length gives us a different image distance and everything. Same works the same. But as you can imagine, for your eye, the lens in your eye works the same way, but it has to be flexible so it can change its focal length and for a given object that's different distances away. So you're looking near versus at something close to you versus looking at something far away from you. And that's why people who need glasses, myself included, now that I'm older, right? I need reading glasses now. The lens in your eye, the front of your eye, becomes less flexible. So you need help focusing. And that's what the glasses do. It helps with changing the focal length of the lens in your eye. All right, so let's continue and go back to the slides. We okay so far? All right, so you can see, as you can see, all right, the image was upside down. It was inverted. All right, let's go on to the next slide. Let's do our thing here. All right, oops, I don't want mirrors, I want lenses. Converging lens, all right, converging lens. Right, you can see as we change the object distance.
We still see the PowerPoint.
Oh, I'm sorry. Let me see if I can figure out how to do that. Stop sharing and start sharing on a different slide. Here we go. Is there. Is that it? Now you can see the, whoops. Why is the shot sharing stopped? That's not right. That's not what I want to happen. Share. There we go. Right? We good?
Yeah, I can see it.
Okay. So the point here again is, right, here's your converging lens, ray 1, ray 2, the third ray right through the middle, and there's your image. And like I was talking about with your eye, if we move the object, right, the image position changes. And we don't want that to happen in our eye because your retina is always the same distance away from your, you want the image to always appear right at the back of your eye. So the lens has to change focal distances so the image always appears right at the back of your eye, depending on whether you're looking at something that's close to you or far away from you. Right? Now, converging lenses can have a virtual if the object is inside the focal point. Right? And now a converging lens is a magnifying glass. Magnifying glasses are converging lenses when the object is inside the focal length, inside the focal point. Right? Same rules, ray 1 straight in through the focal point, ray 2 from the focal point, and then straight out, right through the center. There's the image appears. But this is a virtual image because that's not where the light actually is, right? That's not where the light actually is. And there's but you can see how that would be a magnifying glass. What you see is bigger than what's actually, the object actually is. Okay? Since we're here, let's just deal with diverging lenses right on the spot instead of going back to the slides. Right, diverging lens, you can see the curve is inwards like a concave lens. And they always give us, I'm going to turn ray 3 off. They always give us virtual images that are smaller. Ray 1 straight in and away from, diverge away from the focal point. Ray 2 towards the focal point on the other side. And then straight, parallel to the principal axis. And then our image, we have to go back, trace back to where the image would be. Right? Let's move the object closer. Ray 1, diverge from the near focal point. Ray 2, head to the far focal point, and then parallel to the principal axis. And there's your image, a virtual image. Good? Further away the object is, the smaller you can see, the smaller the image is. Right, I can make my object bigger, but the same idea. Right? The further away I get, the smaller the image gets. So the image is always virtual. Okay? Let's go back to the PowerPoint. Oops, why is it not continuing? There we go. Right, there's our ray diagram for the virtual image, or for the diverging lens we just covered. We okay? I feel like I'm going fairly fast, but you guys seem to be doing well, okay? Anyone want to see it again? Okay, silence means move on. That's the same exact simulation. I was just going to go back to switch the thing to diverging lens, but we already did that. So we can move on. And I think this is our last slide. It is. Whoops, I screwed up and hit it. Hold on. I screwed up. Screwed up again. Here we go. Last slide. All right. Notice the equation for mirrors and lenses are the exact same equation. Right? The exact same equation. 1 over F is equal to 1 over DI plus 1 over DO, right? It's the exact same equation. The difference is, as you can see below, is the sign conventions. Okay? So you can read the rules. The focal distance, the focal length is positive for converging lenses, negative for diverging lenses. The object distance, again, is always positive. It says, except for compound systems, we're not going to deal with compound systems. All right. Excuse me. So the object distance, again, is always positive because that's where light actually is. And then image distance, again, is positive if the light's actually there. So for a real image, on the far side of the lens is a real image, we have a positive. If it's a virtual image, which would be on the same side as the object, it's a negative. Okay? And again, for magnification, it's negative. In the book, when we do book problems with this, you're going to, because on the formula sheet, it's given, magnification is given as absolute value. So this negative sign is not there. Okay. Any questions, comments, issues? Does anyone need me to stay on this slide for another moment for you to finish copying anything if you are copying? Again, this notes are, the PowerPoint is on Schoology. I have not converted it. Dylan asked me to convert it to a Google slide, so because some of the pictures kind of overlap the words when you're looking at it through Schoology, and I forgot to do that. I'll try and remember to do that and then share it with you on a Google slide also. All right. We good? Or can I stop sharing or no?
I'm good.
Okay. Here we go. Stop the share. All right. So that finishes up the chapter. All right. That finishes everything up in terms of notes and discussions and everything. There are in the book. So today's assignment, if you look on today's assignment, I'm going to stop the recording.